Hi, welcome to MyProjectBazaar.com. Our process is CrowdOp query optimization for declarative crowdsourcing system. Let's see the abstract. Declarative crowdsourcing is designed to hide the complexities and relieve the user of the burden of dealing with the crowd. The user is only required to submit an SQL-like query, and the system takes the responsibility of compiling the query, generating the execution plan, and evaluating in the crowdsourcing marketplace. A given query can have many alternative execution plans, and the difference in crowdsourcing cost between the best and the worst plans may be several orders of magnitude. Therefore, as in relational database systems, query optimization is important to crowdsourcing systems that provide declarative query interfaces. In this paper, we propose CrowdOp, a cost-based query optimization approach for declarative crowdsourcing systems. CrowdOp considers both cost and latency in the query optimization objectives and generates query plans that provide a good balance between the cost and latency. We develop efficient algorithms in CrowdOp for optimizing three types of queries: selection queries, join queries, and complex selection queries. We validate our approach via extensive experiments by simulation as well as with the real world. This is the flow of our process. Initially, the data extraction process will extract the data set and load the data into the database. Then the fill operation will replace the misfilled data by using the best match value and reload the database. Then the relation classification method will classify the data set into multiple tables and load these multiple tables with a common attribute inside the database. Then the query plan approach will fetch the query values for select, join, and complex query types. Then the query optimization process will optimize the result for the optimization query type values. Then the crowdsourcing executor process will estimate the result by estimating the query execution results. And finally, the cost and latency calculation will be computed by using the query comparison method, and the best query type, the lower cost and latency will be calculated. Let's see the demo of our project. Click on run button. Here we have to initially click on pause button to fetch the data set. Choose the data set from the location you have stored. Click on dataset folder and click OK button. The dataset value will be displayed here, and by clicking on extract button, the data will be extracted from the dataset file into the SQL Server database. The records are inserted successfully. Click on OK button. Here, by clicking on view extracted data, the inserted data set will be extracted and it will be shown here. Here there are three misfilled attributes are displaying. One is dose, horsepower, and price. By clicking on apply fill operation, the misfilled attributes will be filled by the default values. Once the fill operator filled all the data, we can view the filled data by clicking on here, and the full operation is processed successfully. Click on OK button. This is the relation classification process. By clicking on classify dataset, the classification process will classify the dataset into three different class relations. Relation 1 is completer. The relation 1 contains the attributes like make, fuel type, dose, body style, and drive wheels, and the relation 2 contains the fields of make, fuel type, cylinders, engine size, and horsepower, and the relation 3 contains the information about make, body style, color, etc. Here, this is the query plan process. Here, the query value is given, which asked how to fetch the make, fuel type, and horsepower, color, quality, price values from the dataset, which is between the value from 10,000 to 40,000 with the color yellow. For that we have three different query type. One is select query, join query, and complex query. By clicking on select query, it will get the corresponding query value with the select command, and the respective operation will be fetched here. Like that we can get a query value for different type of query types. Then click on next button. This is a query optimization process. By clicking on get query type, the corresponding query will be fetched and the optimized query value will be fetched here. By clicking on next, this is the query optimization for join query type. Click on get query button. The query for the join is displayed here, and the query optimization will be fetched here, and click next. This is the complex query optimization process. Click on get query. This is the complex query value based on the condition which is given in the query value. Then click on optimization query. It will fetch the complex it will fetch the data by using the complex query data. Click on next button. This is the crowd optimization process. Click on select to calculate the crowd optimization for the select query type, and the optimized value for select query is 79 milliseconds, and for the join query is 115 milliseconds, and the complex query is 75 milliseconds. Then click on next. It will show the optimization result for a different type of query type with the latency time. Click on select. It shows the evaluation result as 79 and the start and end latency time. Then click on join. It will show the corresponding result, and the complex is 75 milliseconds. By this, the execution process is over. Thanks for listening.